So in this project, I'm going to attempt to add a camera to the Z-axis of the ShopBot Alpha tool that we have. The Z-axis has a dust skirt on it, which is held magnetically, and you'll see that. And my first attempt, and the only thing that I've done is ordered in some pieces that I believe are going to work. I have my GoPro here, and that's what I'm going to use. The GoPro is nice because, I've used them. I've done some hiking, and I've used them to record. The image stabilization is extremely good on the GoPro, and I've got batteries. I've got a large SD card for it. It's relatively light. It's easy to operate, and I'm hoping to be able to get that added to the perimeter of the dust skirt. And my approach is going to be some extruded aluminum, which might be called 8020. I think that's a brand name for extruded aluminum. Actually, it's not unlike the rails of what the rails and the gantry are made of. It's the same type of concept. So the idea will be getting two side pieces bolted to this dust skirt with a cross piece. Underneath, I plan to mount the GoPro upside down, and that's okay because the GoPro will keep that video or photograph stable regardless on the orientation of it. So hanging it upside down is ideal because I can then, the idea is that there's a bolt that you have that runs through the bottom of the GoPro. I have a enclosure for it, not for underwater stuff, but onto it you can attach a light. And this video is going to be the discovery or exploration of whether or not this works. And I'm initially concerned because the aluminum is heavier than I thought it would be. The magnets holding the dust skirt, I'm looking at it, the magnets holding the dust skirt may not be able to handle that very well, so we might need to get creative with how we attach or keep the dust skirt attached once all of the gears attached to it. But in future videos, I want to be able to have a camera view of what the bit is actually doing, and I plan on modifying the dust skirt to leave some of the bristle on it to capture some of the dust collection, but we'll have to experiment with that. So this video, and I apologize in advance, it is literally going to be a path of discovery. You're going to watch or be able to see exactly the failures, the trials, the success, hopefully. We're going to get it attached. It's just a matter of how we're going to end up getting it attached. So, having said that, let's give it a go. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So what we're endeavoring to do is to get the camera added to the Z-axis of the ShopBot tool. So I'm going to grab the dust skirt off of this. And we're going to inspect it just a little bit. It's being held on with magnets. It appears as if there are 3 of them that are embedded inside of here, here, and then down here. And I can see that on the plastic itself, and underneath, I can see that there's 4 of them actually. There's one up here. So the problem that I've got, my concern is, will the magnets hold this onto the bottom of the dust skirt, the top portion of the dust skirt, without it falling off? Because what I'm going to add to it is actually not light at all. So I'm going to swing the camera around, and we're going to look at a workbench and see if we can lay these parts out and try to actually figure out, is this going to work? Let's do that now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So let's take a look at the parts that I've accumulated. Again, what we have here is the dust skirt, and my plan is, this is the way that it looks like when it's installed on the machine. This is the front end of it. To add a rail here, and then a rail here, and mount the camera underneath this rail, looking towards the cutting end, and removing these screws and modifying the bristle by removing the front leading edge of it so that we can actually see the bit cutting, but retain the backside, but we'll see. Again, the concern is, will it hold the weight? Now, let's look at the camera first. This is a GoPro 11. I have owned a couple of these. I do own a couple of these, and I've owned them for basically recording hiking is what it is. And the hiking is all good, and the camera's really awesome for that. But the reason I'm trying to tell you what the bottom line is here is because the image stabilization on the GoPro is really awesome. When you're hiking, you're walking and your arms are going out like this, and it really does a great job at keeping it stable. And I've got videos uploaded of hiking in the Grand Canyon showing how stable it is. So my idea is that this will be very appropriate for the application on the tool. Now, what's the other reason that I like this is because, let's see. See how that image locks? So when I'm in this orientation, I have my finger in front of it, the horizon's the right side up. When I go vertical, the horizon's the right side up. When I hang it upside down, which is the plan on the tool, the horizon will be the right side up. So I plan on hanging it upside down so that it will be like this and not in its standard mode like this. So that's why this ought to work out really well. So that is at least the hope of what we're dealing with. So we'll power this off. And also I have a snap-on light that goes with it. Take a look at that light just for a moment. Okay. Get that snapped into its housing. This styrofoam or this foam buffer over the microphone, I believe, is very helpful as well. Let's slide the light on top of this. Let's now power it on. Camera's on, lights on, different luminosity settings, 4, and then 1 flashes. Obviously, that's not appropriate for our use, but nonetheless, one of those are probably going to work out really well. So I have expectations. I didn't weigh this. It's not very heavy. But the bottom line is the aluminum that I had planned to put on the side of the dust skirt is not light. So we'll put this all aside. The concept is the way that the GoPro works is, you know, you're going to get it onto this fixture that's here. There's a bolt that's going to run through here, holding it all together, and this is what I'll mount to the underside of the aluminum rail. Probably going to have to drill and use mechanical fasteners for that, or at least that is what I'm expecting to have to do. Now, let's take a look at the business end of the aluminum. So these are not light. These are 1.5 by 1.5 extruded aluminum, like a T-slot sort of extrusion. I don't know what this is called, but I've heard this referred to as 80/20. I believe that's a brand name, but I don't know much about it. So I've got 2 of those because the shipping charge on 2-foot lengths was less than the shipping charge on 1 4-foot length. And we can start to take a look at the concept. Something like this. These are going to be cut to length, and I'll take one of these pieces and place it right in here. Now, all pretty massive what's happening here, but yeah. So what my concept is to get plate, something like that. These are longer than I had thought they would be. Yeah, Shouldn't be a problem. We'll be able to bolt through here. So the concept is, you can't really see much of it, but I've got a drill press, a bench drill press there, and I'm going to drill through the dust skirt. I'm going to drill these holes right through here. And then I'm going to use bolts, and I'm going to bolt it together, bolt these on there, and then bring this to the underside of it. Okay? Do that on both sides, and we should be in real good shape. So let's pull these bristles out and see what that kind of looks like when we do that. Yeah, the screws that are there. Yeah, let's do that right now. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. Okay, let's pull that material out. Now, I haven't, I'm relatively new to CNC work. I have not broken a bit yet, but I did have a hold down or fixturing slight snafu where the dust skirt hit a clamp that was at zero, basically nearer 000 basically, and as the spindle moved, it dislodged the dust skirt, allowing it to drag along. So I got a little bit of tool mark on the inside, but didn't damage the bit. And all the damage to the dust skirt is internal, and I wouldn't go so far as to say that it gives it character, but it is a learning experience. So I'm going to pull this out, and I've never pulled this out, so I don't know what I'm going to encounter when I do that. Obviously, this is manufactured in such a way where it can come apart. And this video is going to prove to be very likely epic in length because I am, well, admittedly, one take is pretty much what I do. I may go back and have this edited for the highlighted points. This is, as I said at the beginning, this is a path of discovery. I'm new to CNC, much less modifying a CNC tool. I see there are other screws here. I wonder if these two half pieces are being held together by those screws. But I'm not going to explore that because I don't have any need to separate. These are obviously two separate pieces. I don't have any need to separate these. I don't see any reason to do it. But yeah, that's probably meant to come out. Oh, there's screws on the inside. Okay. Like I said, path of discovery. I would need to be, yeah, that comes right out now. Magnets. This dust skirt would have to come out anyway, or the bristle component. Because like I said, I'm going to want to modify that. Yeah, it's just some specialty brush made by some brush manufacturer. We sell weather stripping. And part of the reason that this tool exists is because we're going to very likely make some custom thresholds. So yeah, sure, that works out really well. I wanted that off so I would be able to get that into the drill press, actually. So I wanted to get that off to also show you what that would look like a little bit better. Being able to basically get the lay of the land before we proceed certainly going to be something that I'll want to do. I'll leave that there for now. So I'm thinking I'm going to get some sort of a fast, no, I think I already have that. We'll discover that in a moment. I'm thinking these bolts go like this, and this T-slot is going to ride inside of the T-channel. You don't have to be too smart to figure that out. I'm going to guess that it goes this way. That to me would make more sense. So let's get this actually just put it on this way. And I've seen this sort of extruded aluminum in the past, and I've always thought to myself, someday I'll figure out a way to incorporate it. I do have a concept of making a desk, having a desk, but then making at the desk, making a desk that's going to look like, desk is going to be a circle. Your chair will be here. Monitors will be around the perimeter, because a lot of monitors is just a way to be really productive, in my opinion, but creating a geodesic dome over the desk area. Now you're sitting here, and it would be a dome where the monitors would literally fill that dome. Anyway, I thought I would use that material because you could have this stuff put together on an angle with elbow or pivoted sort of connectors. Let's see what this looks like. Yeah, just like downtown. You betcha. That's the concept. We're going to tighten that up, and that'll bolt right down to it. So what we're getting at with that is what? No. Yeah, here's what we wanted. Well, yeah, actually, this is what I want. This is what I want? Yeah, this is what I wanted right here. Something not unlike that. So now you start to get the picture of what that's going to look like. Drill through the dust skirt, machine bolt it together. So now the next thing that we'll have to do is figure out what length to cut these at and whether or not to butt them together or miter them. So I've got enough aluminum for the two sides and the front piece, the front end. And at the front end is where we're going to hang the camera here. So what's going to have to happen is this is going to have to get attached to the aluminum here. It'll be like this. The other concern I have is how much distance this takes off. Sorry about the rolling camera. I don't have the tool turned on, so I'm not going to fire it up just to get an idea of what that's going to look like, but let's kind of take a look. Yeah, so that bit's coming down. This is in your welcome pack when you get a ShopBot. It's actually quite handy. So the standard bit I have in there is coming down. The standard chip breaker I have from Onsrud, it's hanging down 4" anyway. And with the length of the bristle, is about 2¼ inch. So I think there's going to be situations where we're not going to be able to get the camera installed because I don't have a lot of play. But we do have a small amount regarding the height of how this is going to be installed. Oops. Yeah, it's not going to work. Take a look. Take a look and see how much room we've got on the height, the attachment. This is basically how you play with the height of the dust skirt. Keeping the tool clean is basically a full-time job. It's like what they say, what I've heard said about Ferraris: for every hour you drive them, you've got 2 hours of maintenance. So I've got that sucked all the way up just to see what kind of height this could potentially yield us. And I'm thinking that the design is not going to really accommodate many installations that I want to do, many applications. But I have had the idea of a webcam, like the one I'm obviously using right now, with a long enough USB cable, and literally running it through the wire chase of the tool. As you can see, the track right here at the top. Okay, well, that track, that wiring goes all the way back, and then on the rear of the machine you can see the track there. So we'll see what happens with that. For right now, let's measure what that brought our height to. It may be pretty strong. Yeah, that brought that clear opening up to about 4.5 inch. So it opened it up a little bit. So we'll leave it there, and the concept again now is going to be something bolted to the side, another track bolted to the side, and then in the middle, hanging the camera off down here, and with any luck it might capture something if we're in such a position to be able to have the clearance needed. If not, we will work on a modification where we get a, we'll see if a webcam will work on the PC with a 20-foot USB cable, because that's pretty much what it would have to be. And that's what we're going to be looking at. So at this point, what we're going to do now is take a look at the rest of the parts. So let's go back over. You know what, let me show you that. Your camera angle was probably a bit challenged. So this was basically what I was measuring, what kind of room we had in here. Okay, so, and that's of course with the Z. Well, I didn't mention that. This Z height is 2 inch. So obviously we've got more room. So if we create a Z location higher, let's see, what would we do? Well, we'll need a longer bit to have a Z location. Would incorporate more contraption hanging down. So let's get back over to our table. Let's take a look at the other components that I have in the box. Okay. So the idea will be to get a couple of these brackets on either side. Kind of witnessed what that's supposed to look like. This is going to be camera related, so we'll close that up. And let's just explore some of the additional parts that we have here. So we've got brackets for this side, no big deal. We've got the T-nuts. We'll move those out of the way. We're going to cut them both. We're going to take one of these pieces, recut it, and put it in here, obviously, is where that's going to go. I have a couple of inside corners to bolt all this together. Here, and then the other piece. I'll tell you, this aluminum is not inexpensive. That is to be sure. Be another rail here. And honestly, I wasn't expecting it to be as heavy as it is. Then I have a couple of outside corners that might be cool. They don't make them in the color I want. Like this. Yeah, I was thinking this. And this will actually bolt to the inside of the unit in both orientations. So it'll bolt all together right to the inside of the profile here at the tip of my finger. So that might be an elegant way to hold it together. We'll figure it out. Or maybe I'll use both to make it strong. The concern that I have is I want it to be very rigid. So that when the machine moves, it's not creating a situation where even the GoPro with its very good image stabilization is having a problem keeping it stable. I expect it's going to be extremely stable because of my experience using it in a hiking environment. So I'm thinking it's going to be really good. Now, I think that what's remaining here are my initial bolts for going through the dust skirt. I've got some 1/4 20 by 2 inch aluminum machine bolts. And I just picked these with the idea that, well, I'm going to have to test. I've got some shorter ones because I believe I'll use shorter ones over here where there's less wall thickness. That should work out really well. I'm sure I have some washers. Yeah, aluminum washers. Excellent. And some 1/4 20. I tried to get 1/4 28, but I couldn't get it all in aluminum. Aluminum nuts. For the weight, for the compatibility of the base material. So, these are the parts. With any luck, something's going to work. The next thing we're going to do is get the drill press set up right there. I'm going to design how I'm going to try to mount all of this together and see what happens. So this video now is going to phase into probably just recording me setting up the drill press because I'll need to get that set up no matter what. So thanks for continuing to watch, and let's move on this path of discovery. Thank you. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience. And hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. So here we are the next day of adding the camera to the ShopBot project. And what I'm doing right now is getting ready to set up that drill press. And the sound you hear is just the ShopBot doing the spindle startup routine or the warm-up routine. So I'm going to pause this video until ShopBot is done because I'm afraid that'll cause too much noise. So as soon as that warm-up routine is done and it goes through different periods of time at different RPM, whether or not I'm going to cut on the machine a particular day, and I don't believe I will today at all, I always warm up the spindle just so that I'm warming up the spindle. So let's pause this and we're going to start setting up this drill press. Okay, so the machine has completed its warm-up routine, so now it's not very as loud in here as it once was. The more I think about it, the more I'm going to create a well edited video where we're only looking at the important highlights of everything that we're talking about here. So going through the trouble of getting the drill press, I think, is important because I want to be able to drill the hole straight rather than trying to freehand it. I simply don't want to freehand it. Okay, so let's take a look at this. This is I believe this is a bench version. I'm quite sure it is actually. I don't have much experience with Porter cable outside of routers and equipment that's specific for use for doors. I like their routers a lot, their hand routers. All right, and the business end of the tool. I also bought this because it was in stock. And I didn't do a lot of research, but the name Porter Cable, like I said, is one that I trust, or I've had good luck with. And this is just consumer quality material. That's all I need for this project. I don't have a need to have anything more robust for, in terms of a drill press. At some point in the future, perhaps I will. I don't right now. Chuck. Batteries, there's batteries for this. I must admit, I'm not sure what would be battery powered. Oh, there may be a light. Maybe a light. I'm not actually not sure if there is. Yeah, there is a light. I can see that there is. I am aware of the very real possibility that this is going to turn into a fail and that we're going to need to come up with a plan B on this, because this material is not light. It's aluminum, but it's still pretty heavy. You know, maybe it's going to be coming up with a snap sort of latch on the dust skirt, holding it to the bottom of the dust collector orifice, whatever that part is called. So, first thing to do is look at the installation instructions. Let's do it. Tool safety, additional safety, electrical requirements, the grounded plug, 110, 2 amps, so, you know, a typical fuse ought to have no problem powering that. I will plug it in, you know, I don't expect to be tripping the fuse. Does have a wire guide here in terms of the gauge of wire in the extension cord if you're going to use an extension cord. And what's interesting about that is a lot of what we do is access hardware or low voltage hardware. And what's interesting, as an aside, the further away you are from the load to the power supply, the thicker the wire you need. And a lot of people might initially think, well, that's counterintuitive because there should be more resistance. But actually, and it's not really, for me, it's not a good analogy to use, but think of the diameter of a pipe or a straw. Think of a straw. If you've got just a tiny little straw and you're trying to, you know, take in a lot of liquid through a tiny straw, that's pretty challenging. You use a much bigger, they call them zombie straws, a much bigger, fatter, greater diameter straw, you can pull a lot more liquid. So the greater diameter of a wire, which is a smaller number, 18, 16, 14, even 12 gauge wire in your extension cord, the thicker the wire, the more copper or whatever the conductive material is that's in the cable, the thicker that is, the more electrons are in the wire. Therefore, the more electrons are engaged in the process of movement. And actually, the electrons kind of move backwards, because what happens is they shift backwards in terms of the flow of current, because they're constantly, if your current's this way, they're constantly coming to hit the current, and it continues, the electrons flow in this fashion, even though your current's going in this fashion. So it's pretty neat. So the greater the diameter wire is more electrons, therefore more current can flow. So if you have a 1 amp, a 3.2 amp load, and you're 50 feet from the power supply, a fixed amount of power can be delivered through a circuit. Let's say it's a 15 or a 20 amp circuit. If you're 50 feet away, fine. If you're 250 feet away, that might be a problem, because the conductor may not be able to let enough electrons move, and that would cause an overheating, maybe a short, things of that nature. So you have to be mindful of distance from the power supply to the load, how many amps are going through there, and what gauge of wire you need. And any hardware, most hardware is going to have, or you'll be able to get your hands on a wire chart. How many amps, the distance, therefore what gauge of wire you need to have for the conductor. I saw it and I thought I would mention it, so it's interesting, I suppose. I don't plan to be more than 25 feet away, so a very light-duty extension cord would work. Now, what I like about instructions when it comes to hardware, like door closers, good instructions list, here's what's in the box. So the first thing I do is make sure I have everything, because I don't want to do a IKEA situation and I've been there for 90 minutes and I'm missing one odd bolt that I need. They also tell you what you need to put it all together. Yeah, we'll assemble that as needed. So we've got the drill head here, the head assembly, the table assembly is here. Base is here. The feed handles, of which there are 3, 1, 2, 3. The chuck and key hardware is E, and I have that and that. Column assembly is F, well that's this. The hardware bag is going to have the lock handle, the crank handle, probably the lock handle, the worm gear, I would say that that's the worm gear, hex wrenches, of which there are 2, hex bolts, of which there are 3, rack. Oh, rack. Oh, that's here. It's already attached. Yes, it's attached. And then the rack ring, which is this. So this assembly apparently is done. So I've got all of G. H are a couple of AA batteries. And there is a light here. I can see the light bulb down in here. So I won't bother to show that to you, but it is there. So we've got everything on the table of contents. Now, know your drill press. I find it really handy to know the names for things so that when I'm reading the instructions, I know what they're referring to. So we have depth scale pointer, depth stop, on-off LED lights, light on-off LED lights, light switch, quill return, I'm not sure what a quill return is, quill return coil spring, LED light, rack ring, table lock handle, bevel lock bolt, okay. Yeah, I guess if you want to put this onto a, onto a bevel, you'll be able to do that. Our holes are going to be straight. Feed handles, of which there are 3, you can see them on the side of the tool. Motor pulley, spindle pulley, I don't expect to get underneath the head of that. Chuck key holder, pulley cover, belt tension lock knob, and be on the other side of that. Motor, hex head lock screws, on-off switch safety, on-off switch with safety key, chuck, table, mounting holes, rack, column, table crank handle, table bracket. Okay, so, and then there's a glossary of terms. I'm going to skip over reading those. So it says it takes 25 to 35 minutes to assemble this. Okay, so let's get started. It says, let's get started with this. Okay, so assembling column to base. Position the base on a flat and stable work surface. Must be able to support 100 pounds. Okay. Place the column assembly 1 on the base. Figure A. Column assembly 1 on the base. Now what's not clear to me is the orientation of the rack, and that's why it's handy to have that here, because it does show us where the rack is. Yeah, this rack can be moved around, so it doesn't actually matter. It's going to have to get repositioned, and that's certainly what one of the hex screws are for. So place column assembly on the base, align the 3 mounting holes of the column assembly to the holes of the base. Bag G, locate the 3 hex bolts from the parts bag. Place a hex bolt in each of the 3 holes in the column assembly and thread into the base, tighten with a 13mm wrench. This is where it would have been helpful to have assembled all the tools necessary. But I will obtain a wrench. It says a 13 millimeter wrench, so they're meaning a box wrench, but I doubt that I have a, I might have a 13 millimeter box wrench. I doubt it. I do have a crescent wrench though. Got two of them down, seated all the way. This one's going to need, oh, there it goes. This material, very quite likely being manufactured somewhere in Asia, would explain why it's metric, would be my opinion. And those holes aren't drilled really straight or perfectly straight, but I'll get it as centered as best as possible. Okay, so we've got that step completed for us. Installing the table. Bag G, install the lock handle, install the table lock handle. Now we're in figure B through F. So the table lock handle is part 1 into the hole in the rear of the table bracket, which is here. Yeah, you've got a tapped hole on this side, so that's where that's going to go. Note, install the handle from left to right so it enters the non-threaded side of the table bracket first. Sure. Bag G, insert the worm gear into the table crank handle hole 3. Okay, so worm gear is going to go through, yeah, through here and out here. Definitely, that's what it is. Definitely. Okay, so install the handle from left to right. Okay, insert the worm gear into the table crank handle hole from the inside of the table bracket. Make sure the worm gear meshes with the inside gear. It does. I can see it turning here when I rotate that. There's only one way for it. Yeah, I'm just holding it in too far. Okay, looks good. Do not remove the lubrication from this worm gear, right? It's heavily lubricated in there. Place the rack 5 into the inside of table bracket 4. Yeah, for sure right now we're going to have to reposition this. I can see that. So Position the rack into the inside of table bracket as shown in figure C. Aha, yeah, that makes sense. I guess what I try to do is to have a reality check understanding that it actually works correctly before I continue. And the arrow stamped on the rack is pointing up. Yeah, okay, so we're good. This appears to be okay. No, I also like Delta as well. I have a Delta bench grinder. I'm very happy with how smooth it works. Slide the table with the rack onto the column. Okay. So that, at this point, that collar is going to have to come off. Arrow pointing up because the orientation of the gears on the rack. Yeah, nowhere for that to go at this point. So I'd say that that's going to sit down. Except it's probably going to need to be over here. Neat. Slide the table with the rack onto the column. We've done that. Engage the bottom of the rack with the lip of the column assembly. Yeah, got it. Tighten the table lock handle 1 to lock the table to the column assembly. Okay. Well, we've got that reasonably locked on there. Okay, it's locked. Now it doesn't rotate. Rack's got a small amount of play. Do not over tighten. No, we've not done that. Install the rack ring onto the column. That's the rack ring. So the top of the rack fits into the rack ring. Got it. An Allen wrench does not fit very well on that. To avoid column or collar damage, do not over tighten the set screw. Yeah, you could easily strip that out. That's what would happen. The bottom of the collar must not be pushed all the way down onto the top of the rack. Make sure the top of the rack is under the bottom of the collar and that there is enough clearance to allow the rack to rotate freely around the column. Oh, yeah, sure. Okay, yeah, it makes sense. So you're going to loosen this and need to pivot this around, so this can't be too tight. And I do believe, no, it might be okay, actually. It's not super tight. Yeah, we're good. Really good. Happy with that. Tighten the set screw using the wrench. Now install the table crank handle 8. And I already know what that is. Here it is. This is your table crank handle. Install this onto the worm gear shaft 9. Yes. on the side of the table bracket. Line up the flat side of the shaft with the set screw, which is here, in the crank handle, and tighten the screw with the 3mm hex wrench provided. Do not over tighten. Can do. Just like the collet on the spindle, you tighten it in just one little additional flex. Stiff on that movement, but the only stiff on the movement is me not loosening the table bracket. Down smoothly, reasonably smoothly. Just not loving how, I mean, that's loose. Just not loving how that works. I'm sure it'll get smoother with time, but regardless, there probably won't be a lot of variation that's necessary in terms of heights. Okay. Anyway, not a showstopper. Line up the flat side of the, okay, we've done that. Okay. Carefully lift the head, the business end, and slide it onto the column too. Make sure the head slides down over the column as far as possible. Align the head with the base. Tighten the 2 head locking set screws, which are 3. We're going to discover where those are before we do anything. On the right side of the head by using the provided 4mm wrench. There's oil on all of this naturally. Let's take a little bit of it off. Let's say that these are the 2 screws here and here. Looks right. Curiosity get the best of us right now. I did check to make sure that those screws were drawn in, and they were. As far down as it's going to go. So align it, sure. And then tighten it with the 4mm hex wrench. I want to strip that. Okay. Install the feed handles, bag D. Locate the 3 feed handles in the loose parts bag. Thread each feed handle into the threaded holes on the hub assembly and tighten. So that's pretty easy. That's these pieces. I don't have much left to install after this. Got the chuck and that's about that. I'm not loving that. What is that so? Oh. Just going to leave those hand tight. sure what the total travel is of this. It's not going to be a problem. Oh, I can tell you what it is. It's 2-inch. There's a gauge on the left side. Before any assembly of the chuck and arbor to the drill press head, clean all the mating surface with a non-petroleum-based product such as alcohol or lacquer thinner. Any oil or grease used in the packing of these parts must be removed, otherwise the chuck may come loose during installation. Okay. So there is oil in here, and I'm going to pause this video and clean that according to the way that it says, because I'll need to leave the room to do that. Alcohol or lacquer thinner. Yeah, I've got lacquer thinner, so let's do that. Clean that very well. On. Clean out the tapered hole in the chuck with a clean cloth and a non-alcohol based cleaner. Wipe clean all the oil residue, any dirt grime thoroughly. It's actually clean. Clean tapered surfaces of the spindle. That's this. Note to be sure that there are no foreign particles sticking to the surfaces. The slightest piece of dirt or oil residue on any of these surfaces will prevent the chuck from seating correctly. This will cause the drill chuck and bit to wobble. Open the jaws of the chuck by rotating the chuck sleeve clockwise. They're already open. They were open. Unlock the table lock handle and rotate the table away from the bottom of the chuck. So loosen the table, rotate that away. Okay. Insert the chuck onto the spindle, pushing upwards all the way. Now let's read before we do anything else. Using a rubber mallet or a hammer and a block of wood, tap the chuck onto the spindle firmly. Okay. Turn the feed handles to lower the chuck to the lowest position. Place a ball joint separator above the chuck and tap it lightly with a hammer or rubber mallet to cause the chuck to drop from the spindle. Insert the chuck onto the spindle, pushing all the way up. Use a rubber mallet or a hammer and a block of wood. Tap the chuck onto the spindle firmly. Okay. Turn the feed handles to lower the chuck to the lowest position. Place a ball joint separator above the chuck and tap it lightly with a hammer or a rubber mallet to cause the chuck to drop from the spindle. Why would we do that? take a look at see what they're talking about. Okay, well, who's got a ball joint separator laying around? See what it is. Okay, so I guess what they're saying is, should you need to remove the chuck, that's how you'll go about doing it. Apparently the way that this goes on is that it's just a tapered spindle, and you're force fitting it onto this, and that's not unusual or unheard of. There's hardware that goes together this way. There's hardware that is a splined shaft that you have to seat onto the arm correctly. You have to get it right the first time. If I think of it, I'll mention it. So let's grab our rubber mallet, which I do have. Yeah, so the ball joint separator is, well, let's get this seated and then we'll talk about what that is. Now, I understand why the it's got to be free of particulate in there, free of, that's why it's so important to clean that. Good enough, I would say. I broke my shopping list. Okay. So, turn the feed handles to lower the chuck to lowest position. Place a ball joint separator above the chuck and tap it lightly to cause the chuck to drop from the spindle. It would have to go in here, and you're just going to tap it off. I suppose you would remove that if you needed to replace the chuck. You may have stripped it, needs to be replaced. So I've never had to do that on any tool that I've owned, but I can see why that would be the case. Yeah, we're looking good. Mounting the drill press to work. Yeah, drilling holes. Got it. So what they're saying is, mount it to a workspace, obviously. I'm going to think about doing that. Hardware is not supplied for that purpose. It's basically long carriage bolts, as they're showing here. It's not a big deal. Bevel drilling. So mounting it to the table. Now, talking about features of this, let's just go with it, I suppose. Yeah, it moves. Can't say I'm too thrilled with it, but this was $180, so not too excessively expensive, so I'm not really expecting the greatest of the greatest. Getting the picture. All right, well, let's move through the rest of the instructions just so that we're not skipping over anything that's important. Bevel drilling. A bevel scale has been included, and it's here. I can see it on the side, and I would imagine we're going to have to loosen something for that. A bevel scale has been included to measure approximate bevel angles. If precision is necessary, and by the way, we are at 35 minutes, and it said, so 25 to 35 minutes. Okay, so a bevel scale is included to measure approximate bevel angles. If precision is required, a square or other measuring tool should be used to position the table. Sure, you'll bevel it, you'll use a square set up on the angle that you want. Tighten the nut on the locking pin 3. Yeah, that's down here. There's a nut here that I can see that you'll have to loosen in order to tip this table. Just no need to do it. Set it to the desired angle, retighten the bolts. Got it. Spindle. Rotate the feed handles clockwise. So here, okay, we rotate these handles and we can see how far down we're going. Returns back up under spring bias. Spindle quill. Rotate, I'll have to look up the word quill. I'm not familiar with what it applies to here. Chuck and move it front to back. Rotate the feed handles clockwise to lower the spindle lowest position. Hold the chuck and move it front to back. If there's any excessive play, proceed with the following adjustments. Down. Chuck doesn't move. I mean, I'm satisfied with that, but there's no excessive play. If there was, loosen the lock nut 1, located on the right side of the drill press with a 13 millimeter wrench. Turn the screw to, yeah, there's a screw inside of here that you're going to adjust this. There's no play with this. I would imagine that any play is going to cause the spindle to wobble. It says a little play in the spindle is normal. Tighten the lock nut. Okay, quill return spring. The operation here must be the quill, and the quill return spring has to be on this side. Would be my guess. Yeah, it is. There's an assembly here with the quill remove spring. Do not remove the center nut. Okay. Belt tension. We'll know that it's. We'll know what it looks like when we start it. And I'm assuming the belt is tensioned correctly. Open the pulley cover. To unlock the belt tension, turn the belt tension knob. Okay. Open the pulley cover. Well, this is the pulley cover, but if that's a knob, I'm not sure. Oh, okay, it's just a snap. Yeah. So this belt looks really nice and tight. I'm not even going to bother to show that to you. The belt's tight. That just snaps down. So this is going to be how to operate the tool. Belt tensioning, installing the batteries. Open the battery cover 1, which is open the battery cover 1. All right, well, it's, I guess, okay. So this is the belt tensioning knob is what I've got here. Tighten it to keep the motor in position. Okay. Install the batteries. Those are on the opposite side. Here, from what I can tell, this snaps. There we go. A couple of batteries. It says be sure to use batteries with a 1.5 volt. AA batteries, AAA batteries, they're all 1.5 volt. So I would say that this is a 3 volt light because there are two 1.5 volt batteries. So they would be wired in series. When you connect the batteries end to end, it's additive. So batteries in series are additive. So if you've got two batteries in your remote or in the light, two AA's or two AAA's, it's a 3 volt system. If you had two batteries wired in parallel, two AA batteries, it would be a 1.5 volt system. The difference there is how many amp hours you'll get. When you put batteries together in series, the voltage is additive. And let's say, for the sake of argument, that one of these batteries will last 9 months, normal use. If you took two batteries and wired them in parallel, in this case, you would need 4 batteries wired in parallel to achieve 3 volts, but you would then double your amp hour. So your 9 months would theoretically become 18 months. That's, if you ever look at your batteries and they're stacked end to end, that's how many volts per battery, you add them together. Okay, another low voltage talk. Basic drill press operation, don't mix old batteries and new. Now, they give you information in terms of the RPM. Forgive me, that's going to be really important. In the sense of, I don't want to drill anything at the wrong RPM, because that's just pure science. So we're definitely set to 610 RPM, so a very slow RPM. Because I can see how our motor has the battery, the belt's on the lowest part of the pulley on the motor side and the largest. So we're at a very low RPM. I'll change it if necessary. I don't believe it will be. Yeah, it says right here on the underside of the cover. I don't believe you can see that. But anyway, there's a label right here, and it's in the manual. Oh, there's a drilling speed table as well. That's awesome. So, boy, they want me ramping up the speed, that's for sure. Wood, aluminum, zinc, brass, yeah, 2800, for wood. The only time you'd use 610 is for iron or steel. So they're assuming you're going to be drilling, steel with this right away. On-off switch. On-off switch has a removable safety key. Yeah, for sure. Oh, here it is. Yeah, apparently, this front part is going to come out. Pull out lock. Yeah. So now it's not going to work. You don't want somebody using the tool, you take this little plastic part out and take it with you. We'll leave that in. Rocker switch for the light is what we just snapped off. Great. Installing drill bit and chuck. We'll do that when we're getting ready to drill. Drilling to a specific depth, drill a hole. Basic operation. Fixturing material down. Yeah, I'm going to have to think about how I'm going to fixture this down because I don't want, I'm going through the trouble of a drill press. I'm not going to freehand it at this point, so I'm probably going to get a couple of basic compression clamps here and just hold that down so when I'm drilling straight. There's a drill press vise. That's a separate item which is not included, which would be really nice to have. I'm going to look into that. Drill press vise. And that's it. Then after that, it's maintenance. So what we're going to do, before we get on to the business of actually doing some drilling, let's just plug it in to make sure it works. And then we'll end this part of the video. No whammy, no whammy, no whammy. All right. Light first, huh? All right. Batteries work. Yeah, it's nice because it shines right down here. Nice. Spindle is nice and straight. All right, it works. Next part of this video, we're going to figure out how to fixture and hold that down. Let's move on.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.